All right, so I'm going to go over the study guide for Chapter 7, which is similar figures here. Won't necessarily go over every question, but might hit on a couple here that are similar to each other. So these first two are relatively similar. Both of them are proportion word problems. For this one, your proportion would be 1/8 of an inch is to 12 miles, as 2.5 inches is to what miles? So you would solve that proportion. 1/8, if you need to do it as a decimal, should be 0.125. So let's see. I believe you should get 240 if you cross multiply and solve that. 240 miles. Number 2 is going to be a proportion as well, but you're doing it for basically two similar right triangles. One of them being the person and their shadow and their height. So John's shadow was 5. He's 6.1 feet tall. The shadow of the building was 32 feet long. So we would be solving for the height of the building. So we're going to use a proportion there. There's a couple different ways you can set that up. You can do 5 over 6.1 is the same as 32 over x. As long as your cross products are multiplying the 5 times the x and multiplying the 6.1 times the 32, you can set that up a lot of different ways. That's how you set that up and solve it. I'm not going to go through solving that. So moving down here to some of these proportions, I'll pick maybe the hardest one to do. So maybe number 6 here. Whoops, let's go back. Do that. Should have grabbed a calculator. We'll do this first cross, which is 3x times 28, which is 84. And then when we multiply the other ones, we have to distribute. So 35 times 3 is 90 plus 15, which is 105. And 35 times 6 is 180 plus 30, which is 210. Okay, and you'll subtract your 105. Looks like x is going to be a negative number here. Subtract your 105 from both sides, so that's what, negative 21. That looks good, because now when I divide, I'll get a whole number. So I divide by negative 21, I should get negative 10 is my answer. All right, so that's solving a proportion. Number 7 says write 2 additional proportions that would be equivalent to that one. So you're just rewriting with a, b, x, and y so that your cross products will still be the same. So if you look here, the cross products will be a and y will be grouped together, and b and x will be grouped together. So as long as I write a proportion where that happens, it's going to be equivalent to the one that's already written here. So, let's just switch. So let's make b on top over here, and let's make x on the bottom over here. And now that cross product will be bx, and you could leave your a and your y on the same side. So that's one way. You can do the same thing. So you have b with x on the bottom on the other side, and then just put the y over here and the a over here instead, and you still got the same cross products. So there's a couple different ways you can do that. A good question to ask, related to this, would be having a couple different proportions written, and you choose which one is not equivalent. So it might be 3 that are and 1 that's not. So that would be a good question to ask there. Similar figures, just looking to find the scale factor, making sure it's the same for every side length. So this one has a scale factor of 3, and that is the case for all 4 side lengths. So that one's going to be yes, it's similar, and the scale factor will be 3. This other one is going to be no. So the scale factor, if we go from left to right, would be multiplying by 1.5 for that side length. It's also 1.5 for that side length. It's 1.5 for that side length. However, 10 times 1.5 is not 18, it's 15. So this 18 would have to be 15 in order to call these similar. So this is not similar. Number 10 here, a triangle EFG. If HI and GF are parallel, find the length of EH. So if HI and GF are parallel, what we have are two similar triangles. The larger one that I can here put in maroon, so you have that triangle, must be similar to the smaller triangle, which is this one. Because they share an angle, and because they're parallel, they also have these like corresponding angles that are congruent, which means those are, so you have the angle-angle similarity going on there. So we can set up a proportion for this. Let's make this not as thick of text. There we go. So we could do, let's do the small blue one first. So we could say 2x plus 3 is to 4x as this side length is to this side length. So that's going to be a little more work because we have to add these two values together. So EG would be adding these two expressions together. So it's still 2x plus 3, but I have to add 6.5 to it as well. So that's now 9.5 over, and then same thing for this other side. So this long side would be 4x plus 10. And so you're going to do your cross multiplication. You're going to solve that. It's a lot of x's going on here, but what's going to happen is your x squareds are going to cancel out. So when you distribute, you basically have the FOIL method here, or box method, depending on how you were taught. So you actually have four things when you do this cross. So you have the 2x times the 8x, so the 2x times the 4x, which is 8x squared. You have the 3 times the 4, which is 12x. You have the 2x times the 10, which is 20x. And you have the 3 times the 10, which is 30. So this is all just one cross product. And that has to be equal to the other cross product, which would be a little bit less stuff. So it would be 8x squared, and then plus, what is this, 38x, I believe. So you basically have an equation. The good thing is this is on one side and this is on the other side, so they cancel each other out when you move them. So all you have is, if I could write this somewhere else, have more room. All you have is 38x on the one side, and then all of this on the other side. So that's going to be a 32x and a 30. So that's going to end up being a nice whole number. When you subtract 32, you get 6x, and then you divide by 6, you get x is 5. So that's not actually the answer to the question, that just helps us answer this question. It says, what's the length of EH? So we have to substitute that back in. We substitute it in for x, we get 2 times 5 plus 3, that's 13. So your final answer would be that EH is 13. So, fun one there, that's great. Write the similarity statement. Because you have vertical angles and you have parallel lines, the angles that correspond to each other actually cross opposite. So to be careful there. Your x should be corresponding to the 38.6. So it would be like x is the 38.6 as, oh, I guess I didn't, yeah, sure. As 30 is 60. So really your answer is just half of that 38.6, which is what, 19.3? 19.3. We'll skip over that one because we did two very similar questions at the top there. Angle bisector. So an angle bisector will break a triangle into two proportional parts. So since this is an angle bisector, this side and this side correspond to each other in the same way that this side and this side correspond to each other. So like this proportion, that to that, will be the same as this to this. And that is a theorem about an angle bisector that we learned about. So we can set up that proportion. I'll try to color code this. So we have 30 is to 20 as this side length, which is x, is to this side length, which isn't labeled. But we have the whole length of 28. Then we have the other part, which is x. So I know that this little length has to be 28 minus x. So that's what we're going to put here, 28 minus x. And then you can cross multiply and solve that. So I'm not going to go through all of those steps. So we have 28x equals 30 times 28 is 840, I believe. I hope I did that right. But you're just going to solve that and you should be good. This one's not too bad. So this one should be 5 is to 7. So this little triangle as 10 is to 7 plus x. It does should come out to 7, I believe. So x is going to be 7 there. And then we got a lot of different examples that kind of have to do with what we just did. Number 18 is a little tricky. When you have parallel lines and two transversals, you have a proportional relationship here. So 12 is proportional to 3x, as like this side is proportional to this side. So if you set that up, you would have 3x over 12 is 5x over x plus 12. Setting it up that way would actually make it more difficult to solve, because you're going to have a quadratic, you're going to have an x squared in there, and you're going to have to use some things that you learned in Algebra 1 to solve that. So instead of setting it up this way, you could be more choosy with the way you set this up, and I could instead say 3x is to 5x, as 12 is to x plus 12. So you can see how the cross products are identical in the way that I wrote it over here. That's the first way I wrote it. But this way is much better, and maybe you're seeing why. It's because this left side, you have an x over an x in a fraction, so you can just cross your x's out there. And that makes this much easier to solve, because then you cross multiply, you get 3x plus 36 is equal to 60. You can subtract your 36 from both sides to get 24 divided by 3, you get 8. So your answer here should be that x is 8. So if you set it up this way, you would just have a more difficult equation to solve. Again, it would have an x squared in it. You'd have to factor out a greatest common factor of an x, and then set both factors equal to 0 using the zero product property. And you probably don't want to do that. So I would choose to set it up the other way. That's why I put challenging on there, because it kind of depends on how you set it up. It can make it easy or difficult. And then these last two, determine whether Mn is parallel to Kj. So this is the converse of that theorem that we used earlier. If there is a proportional relationship between this part and this part, and then this part and this part, the line has to be parallel that you're using there. So Mn would have to be parallel. So we're just checking that. So we can label this here. This is 32. JL, the whole length, is 80. So if I do some quick math, I can find what NL is there. So 80 minus 32 would be what, 60? No, well, 48. So that's 48. And then we can fill in the other two sides, so 20 and 30. So we can check this proportion a lot of different ways. We can say 20 is to 32, as 30 is to 48, and just see if the cross products are equal to each other. I think they are. I think you get 960 for both of them. And since they are equal, that means we can then conclude that Mn is in fact parallel to Kj. Right, so if we had to write a sentence, I don't think it asks for a sentence, but if we had to explain that, we would just say, since the parts of the triangles are proportional to each other, the lines must be parallel due to the converse of, I wish I remembered the exact theorem, converse of the mid-segment. That's not exactly a mid-segment, but it's one of the theorems that we learned. Last one is, it's the same setup as 19, except you're just finding the value of jn. So you're just filling that in with x. You're cross multiplying and solving for x. So that should conclude the video, because that's the rest of the study guide. There's only one thing that the video didn't cover, and that would be anything about a mid-segment. So I can kind of come up with a quick example here. A, B, C. We'll draw a mid-segment. Let's call it DE. You know, so if it said DE is the mid-segment, that tells us a lot. Usually these drawings are going to have some values in them. One of the values will be either A, B, or DE will be given to you. So let's say this is 20 minus x, and this is, let's make a good example. There we go. So it might say DE is the mid-segment. What must be the value of x? So two things. One thing about a mid-segment is it's always half the length of the opposite of the side that it's parallel to. And it's always parallel to this side. So this is a mid-segment. You know this side and this side are parallel to each other. And we also know that DE is half of the length of AB. So to solve this, I can say that the outside side here, 20 minus x, must be congruent to, and then again, this is only half of the side, so we have to double that. So double of the mid-segment. Right, so if this is half, if this side is half of this side, if I double this one, I have to get this one. So that's kind of what I set up there. Solve that equation, you get 6x here. Gonna run out of room. Subtract 6x, you get negative 7x on this side. And then when I subtract 20 from 6, I'll get negative 14. So when you solve that, you should get 2 for x. That's mid-segment. Wish I had put a question on there about mid-segment, but I missed it, so add that one in there. Thanks for watching. Like and subscribe.